Today we're going to talk about smarter digital experiences and how we can connect different systems that you have on your tech stack, including your CMS, analytics, potentially CRM, APIs, and also how to plug that into vector search and how you can use AI on top of that. So before proceeding, let me ask you this. How many developers do we have in the room? Please raise your hand. Okay, good. Zero. So there will be code. There will be some Docker containers and stuff like that. Just bear with me. It will start in the middle of presentation. So there will be some exciting stuff along the way. My name is Alex. Alex Schedrov. I'm CEO, CTO, and one of the founders of 5Jars. We are a digital agency. And I've been in the Drupal community for almost up to 15 years, even though a lot of people say that I look young, but I've been in Drupal community for 15 years. I still remember Drupal 6 and barely Drupal 5. Just barely Drupal 5. And back in the day, my team, and I was part of the team who pioneered continuous integration and continuous development in Drupal community before it was a thing, before it was DevOps, before it was like DevOps and stuff like that, with a product called CI Box. It's no longer a thing, but we've done that, and also I was one of the contributors for one of the largest Drupal distributions, which is called OpenYMCA. That's the distribution for YMCAs that's been used now by more than 100 YMCAs across the country. 5Jars, we're a full-service digital agency. We build reliable and scalable software as well as products. We're certified Drupal partner, migration partner, received numerous awards as top Drupal agency and top web development agency. We also do mobile development, and we work with a lot of different industries, starting from nonprofits, healthcare, small startups, higher education, health and fitness, and that helps us to kind of share our experience, for example, from healthcare industry with nonprofits. And basically that helps us to bring some innovations from one industry to another. I'm based just outside of DC, really proud of some of our clients here in DC. Probably you know, if you are from this area, George Washington Mount Vernon Museum, one of the largest museums, our client, Catholic Church of DC, a really great nonprofit organization that helps a lot of people in this area, in the DMV area, and a lot of other clients. Also, last year we launched a product that is called ScreenPulse. This is a digital signage platform that helps marketing teams and basically digital teams manage content on the screens at their facilities. For example, there's a digital screen at the front desk. It could be a touch screen. So we build software in order to show the content there, and we also are working on our devices based on Raspberry Pi and a lot of different stuff that we can plug into the screen in order to display content. So what differentiates us from the competitors is that we use a lot of data from APIs. So we're not just another product with like weather application or something like that. We pull a lot of data, we aggregate a lot of data, for example, schedules, programs, and stuff like that, and then display it on the screen. Okay, so now let's get to the business. Let's talk about smart digital experience and why I've decided to do actually that talk. Because today, like 2025, with AI and stuff like that, it's getting more and more complicated to manage digital platforms. So every single month or every single year, we add more and more stuff into our technology stack. And as you can see on the chart, with the tech stack expansion, it gets more complicated to manage all that stuff and to connect all that stuff. So that's why we kind of came up with an approach that we call orchestrated systems. So we use systems that we already have, but we are connecting them together so they will work better together. And why it's important. Tech stack is evolving really fast. the number of tools per team members is growing. Now we use ChatGPT, Claude, Perplexity, Grok. So it's growing every single day. Integrations, well, there are a lot of integrations. For example, if you take Salesforce, you can connect it to Drupal. But marketing teams and digital teams, they're very ambitious. They want to have more touch points with their prospects and website visitors. So that leads us to missed opportunities. So if there is no connection between system, we have to build it. But we have to build it in a way that we can share data between a few different systems. And, well, who doesn't really feel pressure today, right? Everybody feels pressure to do more with less resources, to be more efficient, to do more with less. The tools are great. Drupal is a great CMS. Salesforce is amazing CRM. It knows everything about your prospects or your client's prospect. Google Analytics is a great tool if you find the right report, and that I find that quite complicated, especially with the newer versions. And MailChimp, amazing tool, but none of them knows fully what the other is doing. For example, learning management system. Website doesn't really know a lot of information about learning management systems and so on. So that brings me to the point that there are a lot of disconnected systems. I receive emails like that every single week. Hello first name, or hello Nancy, but my name is Alex. So some crazy stuff. So I think I have a collection of screenshots of fails like that. So, and that hurts engagement. That hurts trust when people go to your website or they use your web application or mobile application. So, and with that, digital teams and marketing teams, they miss really important insights about the users. For example, their first name, which is extremely important. For example, students explored several programs on the website, but there is no follow-up coming in, while kind of marketing and digital teams really want to do that, and they don't want to do that manually. Donor gave last week, but there is still follow-up coming in into the inbox, for example, asking for more, which might irritate that donor, something like that. And now I think everybody heard about context and like memory, short-term memory, long-term memory. So that's, I think, I'm trying to bring that to the level of shared memory across all our applications that we have, mobile application, web application, LMS, and so on. So tools are great, already kind of as I said, but they might work great. Like for example, you can play the guitar or somebody can play the piano, but they should work together. So that's why they need a conductor in order to kind of share the data and share the context between all these touch points and connection points. Now let's think about our fictional college. I would call this Basbridge University. Imagine it in your favorite country in the world, doesn't really matter where, and we will go through the journey of having and looking at this university and their tech stack now, and how with the minimum changes they can connect different systems and get better outcomes. So let's take a look and let's imagine that they use Drupal as their primary website CMS. For example, they have mobile campus applications, so Vue.js and Capacitor, so basically it's a web application, not a native application. Salesforce Education Cloud, Blackbot for donations management, student information system, learning management system. It could be Moodle integrated with Drupal, Salesforce Pardot, Microsoft Clarity, Google Analytics. And by the way, I'm not promoting any of this except Drupal. If you think that everybody paid me, I wish they were, but they were not. So yeah, let's kind of remember that we have like 9 systems here in the mix, but that doesn't really describe the scale. There are way more systems. There might be a data warehouse, data lake, where you aggregate your data, and there might be hundreds of different touch points. So the idea is to kind of connect them through shared memory. Now, Westbridge University, they have a website. They connected it to mobile campus. Then they connected Salesforce with Salesforce Pardot and connected to student information system, because those connections are available out of the box within the marketplace of the Salesforce, and they connected it to Drupal through Drupal module, and there are a bunch of the other tools like the calendar management system, Clarity Analytics. So eventually, we have systems that are connected good enough. So they are connected, they pass data, but what we see across the board, that's not enough for ambitious digital teams. They want to do more, they want to leverage more data, and they just want to do more, because there's always pressure, as I kind of told before. So what goals do they have? Like Westbridge University have really lofty and ambitious goals to increase student enrollment, to develop and scale alternative education, like seasonal programs, online degrees, additional certifications, and all that good stuff. They want to expand revenue on auxiliary service, with marketing, events, dining, and different experiences that they have, as well as they want to grow alumni participation and philanthropy. So basically, almost all kind of higher education organizations, they have similar goals, and even kind of that might be translated to other industries. Everybody want to grow revenue, increase engagement, and personalization, and achieve all these goals from year to year. Now, kind of, I want to walk you through the vision, how we see it, and how we implement it for our clients. And then I want to show you a few examples as a kind of starting point, so you can start experimenting. They will be very simplified, but my goal is to show you an opportunity so you can walk away from the session and kind of start experimenting with the tools that I will show, as well as LLMs, large language models, AI, and vector search. So, and we will walk from kind of disconnected systems to intelligent systems without rebuild. So think about it that your organization or your clients already have all these systems. So you don't need to rebuild. You just need to add one missing piece of puzzle in order for all these systems to work together. So the vision is really kind of, so before kind of going into the implementation, we usually ask a few questions before we start working the project. And let's do the same with Westbridge University. So what if CRM, CMS, LMS, and student information system can share the context among these applications? So what if our website adapted to the users in real time? And what if AI tools knew what users need before they even ask? For example, when they open a model application, or when they open a website. You remember our kind of tools and their connections. So we came up with an approach, and we use that approach quite a lot, that we call context orchestration layer. What is that? It's kind of a simple thing that connects everything, and all these systems can talk to it. So think about like just one API that it's being used by all these systems, or one database or protocol that you can add to already existing systems so they can use it. So think about it that way. Think about it like a shared context, if you will, like term that just came from the AI. So what that orchestration layer does is actually it collects data, pulls key data from different systems. It normalizes it. For example, you might have structured, unstructured, semi-structured data. It triggers some workflows, so it's not just a like database that is sitting there and just doing nothing except storing database. And also it makes your data AI ready. So when you use that orchestration layer, clean up the data. What I frequently say about AI is data is important, so garbage in, garbage out. If your data is kind of uncleaned and you fit it into LLM, you will have the same result. LLM is not the magic box that will transform your data, make it perfect, and then kind of return back. You have to prepare data, and that's what RAG is, like retrieval augmented generation, and we will come back to that term a bit later. And it gives an opportunity to use a modular approach, so it's flexible. You can swap that tool or other tools without login to some specific vendor. It's scalable, so you can scale it. It's replaceable, and it's AI ready. So think about it as like Lego blocks. How does the solution look like? So now let's take a look what we usually consider as that orchestration layer. So first one is just simple and lovely relational SQL database. It stores structured data, but it's not always convenient if you have unstructured data or you want to save unstructured documents like a JSON or something like that. So it's really great to build some relations between tables like users, user sessions and stuff like that, but it's not always a good solution. It really depends on your specific use case. You can use PostgreSQL, MySQL, and Supabase, and way more. Again, they're not sponsoring this talk, unfortunately. You can also use NoSQL databases, such as MongoDB, DynamoDB, Amazon DocumentDB, if you really have like messy data without any structure. One object might have specific property, another one doesn't, or you have nested properties like a JSON with some kind of hierarchy, so you can use NoSQL database for that. If you need some real-time capabilities, you can use Firebase real-time database from Google. Or again, you can use Supabase real-time capability that they have, and we'll come back to that a bit later as well. If you want to have just transactional orchestration layer, you can always use something like Redis or Memcached, but it will be like a short-term memory, and that's what's being used right now in the AI a lot for those conversations. So long-term memory. This is what what ChatGPT knows about you. You know, if you type a prompt, please tell me what you know about me. They pull this from long-term memory, but short-term memory is a memory within your conversation with AI, so they can quickly retrieve it when they need it. And last but not least is a vector search or semantic search, and we're going to dive a bit deeper into those kind of databases. This is great when you need to search for a when you want to retrieve data based on a semantic match. So for example, what's the difference between keyword search and semantic search is that keyword search will look for exact match. For example, if you type in Jaguar, it might retrieve Jaguar as a car or Jaguar as an animal. But with semantic search, if you type in some sentence or part of the sentence, semantic search will understand what exactly you're referring to car or to an animal. So that's kind of the difference between just regular search and semantic search. You can use Weaviate, Qdrant, ChromaDB, Pinecone, Mongo Atlas. That market blows up with AI because AI and LLMs, they are based on semantic search just because they communicate in a natural language, right? And that's why they need to retrieve data based on not the keywords, but the semantic meaning of the words. So we usually use Supabase as an orchestration layer. Even though the list is very long on this slide, we use Supabase for several reasons. First, this is an open source product. It uses PostgreSQL underneath, so you have like a relational database as a part of this open source product. Then it supports auth with JWT tokens as well as OAuth or social media authentication. It also has object storage, so you can basically store your documents or objects or PDFs. You can plug it into AWS S3, so you can store kind of documents. It's not only about like objects, but also about the files that you want to store. It also has edge functions, so you can create your own API in there. So this is really powerful because at this point it really becomes your backend. So it's not only a database, but it's a backend. The really important thing that I forgot to mention is that whenever you create a new table in Supabase, it creates CRUD API right away for it. So you can retrieve information, you can create, delete, update information in the database through already baked in API. So you don't need to create API with Node.js or something like that. It's really powerful, as well as permission policies. So add functions, they use Deno runtime. This is the runtime similar to Node.js, but basically there's some technology behind that. But think about it as creating your own API endpoints. It also has real-time capabilities if you want to stream your events to some devices, which is the case with the Screen Pulse, the product that we built. We need to see if the device is online or offline. So that's when we use the real-time capabilities similar to that. And it also helps with the auto-generated REST endpoint, REST documentation or GraphQLs and APIs. So basically, that database checks a lot of the points from my previous slides. It's a database API. You can also extend that API through edge functions and even stream your events from the database. So in order to install it, it's really simple. You can use Docker container. They have wonderful documentation. Here's an example. You just need to clone the repository, do a few additional commands in your terminal, and then Docker compose up, and your Supabase database will be up. This is type of the database that a lot of startups now use, because in literally like 5 minutes, you already have backend for your product or something like that. So we use that database a lot when we need to spin up something quickly and when we don't want to build a new APIs kind of manually. And DigitalOcean also supports one-click installation. If you want to install it not on your local machine but somewhere else, you can go ahead and install it in DigitalOcean just with a few clicks. But of course, you will need to attach your credit card and start paying for that, at least like $5 a month. That's what the tiniest droplet on DigitalOcean will cost you. So now let me ask you a simple question. How many of you have ever kind of used Supabase in your projects? Okay, good. Okay. Only one. So I hope that now you will learn a little bit about it and go home and play with it, because it's really powerful. Even though it might be not as flexible as you scale it, because there are a lot of redundancy in there and you cannot really control a lot of things, but that's really a kind of a good database to start from. All right, now let's go back to our Westbridge University. And let's think about one use case that their digital team want to cover. So let's say, and I hope you see, yeah, it should be fine, I guess. So let's say a user goes to the website and browses several pages and then submits a web form. That's just like anonymous user. We don't know anything about it. But what we capture is we capture their email and a bunch of other information. So we can track just programmatically, depends on what you use. For example, in Drupal, you can just track what pages they visited, what they've done on the website. So we have their activities and actions, as well as some information that we can attach to their email. And again, this is a very simplified example, but it will show what capabilities that will unlock for you. So we collect this information, and we can then store it in the contextual database, in that Supabase database. So then, after this, we can send this information to an LLM with just a simple kind of API call with the, let's say, OpenAI key, or that could be open source LLM. So we push it there, and we ask, please come up with the user intent. I will show you the prompt and a bit of the code how to do that. That's one of the simplest use cases for kind of leveraging LLM. I know a lot of people are curious kind of right now how to start using LLM. So our approach is we start using it for smallest possible decisions that LLM can make autonomously. Because before LLMs, we had to write a lot of if statements, like if, else, then do that, if that, then do that, where we had to analyze kind of a lot of data. Now we can send this to LLM with some specific instructions and receive it back with some kind of degree of autonomy. And then we receive a response back. For example, LLM can classify that the intent of that user is the graduate programs, just based on the pages that they visited, as well as a really important thing that we use is the confidence. So we ask LLM, how confident are you in your reasoning? And the best practice is to use score from 0 to 1. So usually our threshold is 0.7. So if it's below, we don't trust LLM. If it's 0.7 or above that, we then trust LLM and say, okay, that's the kind of reasonable response if you're sure about it. So yeah, and that's what I personally call like micro decision agent. There are a lot of hype right now about AI agents. I think a lot of people imagine AI agent like a chatbot that you can go ask a question and talk with it. Like in my vision for an agent is something that can make an autonomous decision, even a tiny one. Just go back to an example, like we had to write a lot of if statements. Now LLM can make autonomous decision. It's just a matter of how much autonomy that LLM or AI has, right? If it's chatbot, it has a lot of autonomy because it will talk with you, but again, underneath it's not as simple as just throwing all that stuff into LLM, but that's topic for completely another session. But yeah, think about it as a micro decision agent, and it's already a good starting point, and you can extend it and go from there. After this, so we already know user intent on the website, so we can send this information to Salesforce. For example, marketing team will better understand what user is looking for at the website. We can segment user into a specific group at the part of, which is marketing automation, and send a email blast afterwards, so they will get into the right group. Again, it doesn't really guarantee that all their activities on the website correspond with their intent, but at least my goal is to show you kind of how you can start leveraging LLMs with kind of small transactions, the smallest possible transactions, and learn from it. And again, then it just goes back and we can return back ID and store it in our context database, so we'll understand that this email corresponds to that object in the Salesforce API. So this is a toy example on how the Supabase might look like. Again, we have user intent, for submissions. Of course, you might strip down the personal information before sending it to LLM. It's just a matter of what exactly you collect. But this is just an example that you can start with. Unfortunately, Supabase doesn't really have PHP Composer package and library. They have Python, Go, TypeScript, JavaScript, but they don't have PHP. So that's why I'm referring here to open source package developed by somebody else. But it works, it's simple. Again, according to that code, you can see that you will interact with the database as simple as with MySQL or similar databases. You can search, retrieve, and do all that stuff. And in this example, it's not like a production version of the example. A lot of code is missing from here because it would not fit to the slide, to be honest. So I had to remove a lot of stuff from there. But again, we collected the user information, we inserted it into a database, and that's how it might look like eventually in the database. But again, it's really up to you how much information you want to collect. So now, let's talk a little bit about the LLM. So we use kind of local LLMs in Docker container. This is an example of Docker file that you can just use, and that spins up, in this case, Ollama So it uses Ollama application, and it spins up Mistral with 7 billion parameters, so you can talk to it locally. If you don't want to send your information to Claude or OpenAI, feel free to use local models. And this is a large language model that kind of we call brain model that does some reasoning and returns back results. One of the examples of the prompts, so all we do is just ask, please classify that information and return in a specific format. So we ask it to return it in JSON format, and then on the back end we can validate this. It's really important to validate the response. LLM doesn't really respond 100%. LLM will not respond in a right format all the time. So you have to do additional validation on top of that and validate the object that you receive. That's how it works. But basically we have prompt, we insert their information that we collected, and we ask for certain actions, so please return it back and stuff like that. And then we just send it to an LLM. So here's an example of the edge function with TypeScript. So we just send it to Ollama or LLM of your choice, and we receive the response back. And as many of you know, we can control the temperature on how kind of specific LLM will be. So the more temperature is, the more creative LLM will be with the responses. If you put there 0, it will try, at least try to respond as deterministic as possible with more consistent results. Now, let me ask you this. How many of you are already using LLMs in a way outside of like just chatbots with OpenAI or Claude? Okay, good. Okay, a couple of people. Okay, good. Well, I hope that with examples like this, you will do more, because what I find on LinkedIn, YouTube videos, there's a lot of like marketing fluff about LLMs and chats. It's really as simple as this. We used to build software with if statements. Now we can get rid of them and rely on LLMs. It's not like a magic box that will do some magic and then return back and kind of consume a lot of data. No, it's as simple as just interacting with LLM. Of course, you have to manage memory and a lot of different stuff, but at least this is a good starting point. And yeah, I would love to chat with you guys who already use that afterwards, so we can connect. And I'm really looking forward to learn more about your use cases. All right, so now let's dive into the semantic search and vector search. So I already kind of described slightly that vector search really helps with the semantic search. How it works on the back end, so let's go back to our Vastbridge universities. Let's say they have a lot of data in the LMS, massive courses, videos, images, text, everything that is needed in order to have a great learning experience. So the vector search or semantic search will require one really important step, is converting your content into the embeddings. So think about, let's say, an article of text. So you have to split it into chunks. Let's call it paragraphs of text. And then with the embedding model, you have to generate embeddings, which are huge arrays of numbers. So basically, you transform text into huge arrays of numbers. And then you store it in the vector database. So that's kind of the main idea of vector databases. It's the same good old stuff like MySQL, where we store kind of raw data like text, numbers, JSON blobs, but in this specific case we store huge arrays of numbers. That's it. And again, Supabase supports that. There's a vector extension, Weaviate, Qdrant, DB, Mongo Atlas. By the way, talked to MongoDB this Monday, and they said that in September they're going to release open source version of their vector search. So right now, vector search is one of the kind of key market key products on the market for those who don't have it yet, like MongoDB, for example. But you can use your vector database of your choice. Now, really important stuff is that we don't use large language models for creating embeddings. Because large language models, even in the name, it's a large language model. It's the model that talks in a kind of natural language and that processes a lot of information, a lot of just text in a textual format. Now we need to use embedding model, which was trained on a huge data set of data, so it can transform your text into those huge array of numbers. So here's an example. Just with one line of code in our Docker container, we add an embedding model. In our case, it's nomic embed text. And the important technical detail that it uses 768 dimensions, and I will come back later to this. So just remember that it uses like huge number of dimensions, and it could be even bigger. For example, OpenAI, as far as I remember, uses 1,300 something dimensions. Just imagine like we have 2 dimensions, like X and Y. But in this case, we have like 768 dimensions, but I will visualize it for you just in a second. And you can use domain-specific embedding model. For example, if it's higher education, there are embedding models trained specifically on the data for higher education and stuff like that. So, all right, so how to generate embeddings? For example, we take our text, machine learning for graduate students. We send it to LLM, and we receive 768 dimensional vector, and we store it into a database. As simple as this. This is an example. We can even use curl in order to send it there, and we receive a response back with that vector. It's called embeddings, and then we store it into a database. And how to query an embedding in exactly the same way. So we convert our keyword into an embedding, and then on the backend database, we'll compare kind of incoming input embedding to embedding that is already stored in the database and return result based on similarity. I'm going to kind of discuss the similarity strategy, but just so you know, there are a few different ones. Maybe you've heard about them. There's a cosine similarity that kind of tries to understand the distance between points on the graph and also Euclidean distance. But it's really stuff as you get your hands dirty with like the vector search, you will understand that there are different approaches on how to find this. And here's an example on how kind of 3 dimensions vector look like, right? We have 3 different axes, and we have a bunch of points on that axis. So what embeddings will do, the embeddings will group your points on those vectors according to their similarity. So for example, you can see wolf and dog and cat are animals, so they will be closer to each other within 700 kind of dimensions. And banana and apple, they're fruits, so they will be closer to each other. So those strategies, which is cosine similarity and Euclidean distance, these are the strategy of how vector database will find the closest neighbors, and that's how it kind of finds the information within the database. So it's really, really fun stuff as you start working with it. It's been on the market for quite a long time, but only with AI and machine learning it gets really, really super popular, kind of because everything should be returned in a natural language. And important thing is multimodality. Simple term, might sound really kind of smart and PhD level, but it's really as simple as multimodality is a support of different types of information. So text, images, videos, audio files, PDFs. So when you have that type of data, it's called multimodal search. So you can convert into embeddings not only text, but you can convert videos, images, audio file, video files, presentations, PDFs. So you can then perform a search where you upload image, but receive text from the database back. Or you enter the text and receive image back from database. So you can use kind of your keywords and find videos and everything that is stored in database. Really, really powerful stuff instead of just simple kind of keyword search. That most of us use. And now let's go back to our Westbridge University and how we can use that. How we can use that in our workflow. This is where we will get to the RAG. Again, a very simple RAG. I don't like overcomplicated things, and I believe that with AI and LLMs we should start kind of as baby steps. So that's why I'm showing the really kind of simplified use cases. Of course, in production there will be more complicated, there will be more use cases and edge cases, but let's take a look at this. So that user returns back to the website, and we already know information about that user because we can pull it by the email that we collected. So then we select information from our context database. We already know the intent, the reasoning behind that, and stuff like that. So now we can retrieve based on this, and we don't need to be super specific like we had to be before AI. So we can generate just a sentence in the natural language that this user is looking for creative programs, blah blah blah, and we can set it into embedding model, receive back embedding, then run a vector search, then it will return some results back, and basically we will find some additional information based on user intent. For example, we can pull some courses from the LLM in this case. And then we kind of feed this into the brain LLM and ask like, hey, here are the results, here's the user intent. Please generate simple response back, or JSON object, or whatever you need for your application. And that's what kind of RAG is, retrieval augmented generation. So we retrieve information before talking to LLM, we passed it to LLM with specific prompt, and we received an answer. So we retrieved information, which stands for retrieval, augmented our prompt, and generated response back. As simple as that. And this is really kind of simple example, but very powerful, because here we have an autonomy when LLM can make kind of decisions instead of us writing a bunch of if statements. And then we can just return it back, for example, show on the website as personalization. Hey, check out these courses, or would you like to enroll that specific program, or stuff like that. And based on this, we can schedule a push notification to their application mobile app that they use for mobile campus. So, and then kind of it just returns back. So those are not kind of real-world examples; they're very simplified, but you can just kind of understand the idea on where we can leverage LLMs, whether it's a local one or kind of enterprise like OpenAI, Claude, Grok, Gemini, and stuff like that. And that's how our orchestration layer and API might be connected to LLM. That's how we can use it to just temporarily store the data. You can even ask me like, hey Alex, can we store this in Drupal? My answer would be, of course, you can, but what if you, at some point, you would need to replace Drupal? Drupal is not kind of the best in terms of performance when you have a bunch of data saved in a MySQL database, because there are objects, revisions, and stuff like that. You can use it if you want to get started, but long term, usually we move that into a kind of contextual layer, into a separate database. So just a summary, choose backend. You can start with Supabase and spin it up in 5 minutes. Identify key systems. You can just connect two systems like CMS and CRM, or marketing automation tool. Start experimenting with 1-2 key use cases, and as you get your hands dirty with that, you will understand better how it works, what systems to connect, and what strategies you can use. Use LLM for basic micro decisions. If you need to classify something, summarize something, recommend something, personalization. It's really a tiny thing. You don't need to build a new OpenAI, ChatGPT, or you don't need to build a chatbot, because it will take a lot of time and a lot of effort to just build that. So start with small things, and please don't overthink the LLM. At the beginning, it doesn't really matter. As you build your application, you will then better understand what works better. But at the start, just use whatever is easier to use. If you have OpenAI, generate OpenAI key, put there $20. $20 will get you half a year of experiments like this, because every single token is just 1 cent or even less than that. So it's not as expensive as it might look like. And yeah, with that, I think we're getting towards the end. Smarter digital listeners, they don't require smarter tools. All they require is smarter connections. I'm also running a really small newsletter, curated newsletter on the AI and stuff like that. So if you want to subscribe, we'll be happy to see you as one of my subscribers. My approach is to avoid any marketing fluff and share only kind of useful stuff in there. Because I feel overwhelmed with whenever I open LinkedIn, there's a bunch of different stuff in there. I feel overwhelmed, so I watch a lot of stuff, learn a lot of stuff as I go, so I share some stuff through my newsletter as I go through that journey. And yeah, that's pretty much it for today, and thank you for joining. I hope you learned something, and I hope you will integrate AI into your applications, and that helped you to kind of understand how it works and how to get started with it. Yeah, and I think, happy to take a few questions if you like, or I will just stick around if you have any questions. We'll happy to answer. Yeah.
Thank you.
Yeah. Any questions?
Yeah, I have a few questions, but I'll try to dial it back. So you mentioned about the DigitalOcean as a possible infrastructure. Are there like other infrastructures that you're recommending? You were talking about like the edge. Also, is that like having it at the CDN endpoint edge or something like that?
Yeah. Do you mean for database or like LLMs itself?
Yeah.
Well, I think yeah. For the database, you can use whatever you kind of prefer. It could be DigitalOcean, AWS, EC2. Again, if you want to plug in an S3 bucket to store data, you can do that. Azure. It really depends on the organization and your IT team. Usually, it's like the IT team is bottleneck, right? Because they want to add one more thing into the toolbox, for example, DigitalOcean. For LLMs, it's all over the place. It could be just production API, like OpenAI API, where you don't really care about infrastructure. You just use your key and kind of leverage it. In terms of hosting of the open source LLMs, I know some people who use DigitalOcean to run smaller models.
Okay.
There is a great tool that I personally use. It's called runpod.io. You can spin up open source model there. I usually spin it up for like a couple of hours of work, and then I just destroy it. So, and it costs usually like 20 cents to work with it, and my kind of laptop doesn't really overheat because it's hosted somewhere there. Because otherwise, when I run this locally, kind of the laptop goes crazy and everything just slows down. So runpod.io, that's what I usually use on a daily basis.
All right. And I guess one other question about, you say you know the user's email when they come back. Is that because they're like logging into Drupal with their
Yeah, they can log into Drupal. That's why I kind of said that this is really simplified kind of use case, right? Obviously, we'll not be able to know their email when they come into the website unless they logged in or they were logged in before, and they kind of, we still have that cookie on kind of their browser in order to understand that. Yeah, it's simplified, but as long as we understand who you are and that full information, if it's just like fully anonymous user, we will not be able to do that. Yeah, there's one more question.
I have two questions. One, to piggyback on the question that Dan just had, as much as I love a good DigitalOcean one quick install,
Yeah.
a lot of us in the federal space are on like managed hosting providers, but we are using lots of VDEV and lots of Docker. So like let's say I've got my website, my big meat and potatoes is my CMS obviously, but we've got inputs everywhere, we've got email outreach, things happening, right, in theory, like my client, just a theoretical client. But we are using VDEV, so like let's say what would our orchestration be? Maybe we want to host it in like AWS. For local developers, would this look like containerizing those like local, kind of like you showed the Docker configuration, throw Ollama, throw that in a DDEV, throw that in another container.
Yeah.
But for deployment, if there are lots of layers of abstraction in our stack, in our architecture, what does managing this like start to really look like? Especially when like very complicated like web application firewalls get involved.
That's a really good question. So all these examples with a Docker container, they are most likely focused on just local development. I wouldn't really recommend deploying Supabase kind of for production use inside Docker container unless you kind of know how to do that with like Kubernetes and all that kind of stuff. So usually when we get to the production, we just spin up a standalone Supabase on whether DigitalOcean or AWS, just like in one container, so it will not interfere with other resources and it will not compete for the resources. Again, it really kind of depends on the requirements, firewalls and stuff like that. But think about it as a standalone server for the database. If you have MySQL right now, the approach would be the same for that type of databases. When it comes to model, this is where it gets very complicated. It's Wild West. So you can use AWS Bedrock for government. AWS is just trying to sell kind of AWS Bedrock to everybody, including government. They built a secret data center somewhere on the East Coast. They announced it on the last AWS here in DC. So I think for government kind of agencies, AWS Bedrock will be go-to solution in terms of models. And you can use their OpenAI, Claude, Anthropic, they have kind of marketplace of models as well as they have their own model, Nova or something like that, but nobody really kind of knows about it and uses it except their internal kind of development teams from what I know. But yeah, think about it as just this is a local environment. You can use your DDEV and just add the new services into the DDEV to work locally, but then I guess production it gets more complicated than this. My goal was to encourage you to start kind of playing with it and working with it, locally at least. All right, yeah, that's it. Thank you so much. Yeah.
I got it.